Now the product to sum formulas. Later we will do sum to product formulas. But product to sum, let's start with the two formulas we know already. So here, the first one is cosine of a sum, cosine of difference. And we know the two formulas. And you see, when you do cosine of the sum, you have cosine alpha, cosine beta minus sine alpha, sine beta. When you do cosine of a difference, you have cosine alpha, cosine beta plus sine alpha, sine beta. So let's do a subtraction. It's because when you subtract the second equation from the first equation, we can cancel some terms. You see what happens when you subtract the second from the first? The left-hand side, okay, I just do the subtraction. The left-hand side becomes immediately this one, right? And the right-hand side, when you do a subtraction, so subtract this cosine and subtract this also the sine. And this the cosine alpha, cosine beta will be gone. And we will have -2 times sine alpha, sine beta, because there's another negative of this quantity. So after you do the subtraction, we get a new identity. So this new identity can be easily derived doing a subtraction of the above two formulas. But this identity, you see, we call it product to sum, because let's simply divide the -2 so we can leave the product on one side. Okay, so I do this color code. You can see I can divide -2 both sides. So once you divide -2, this one will be gone, right? This is dividing a -2. So we can write sine alpha, sine beta equals -12 times this difference, cosine of a sum minus cosine of a difference. So that is the formula we now have. It is a product to sum formula. You see, the product of two sine functions can be written as difference of some cosine functions. Yeah, this is our first product to sum formula. And you can remember it. Okay, now I want to get another product to sum formula. Again, what if we do addition of these two equations? So this equation, right, the two equations, we add them. So the left-hand side will become cosine of alpha plus beta plus cosine of, but when you add the right-hand side, you will cancel because these two terms with opposite sign, and they cancel. So we get twice of this cosine alpha, cosine beta. So then immediately, if we add, we will get another identity. This one. You see, if we add cosine of the sum and cosine of difference of alpha beta, and we get twice of cosine alpha, cosine beta, and you can divide 2 from both sides of the equation. Let's divide 2. Just simply divide 2 both sides. Then cosine alpha, cosine beta can be represented. See, this cosine alpha, cosine beta is written as half of this sum. So again, we see this if we swap sides. So just put cosine alpha, cosine beta on the left side, so we can see this. The purpose of that identity is to write the product sum into the sum of two functions. You see, from the product of two functions, right? Cosine alpha and cosine beta is now becoming, sum of two functions. Either sum or difference. That difference is also a special sum. So now we have a second product to sum formula. So the first one we derived was this. That's a product to sum. And you might say this is a difference, right, of two functions, but actually, and the difference is also a special kind of summation, because you add a negative of something. Okay, so this is another product to sum formula. So now we can write sine alpha, sine beta into a, we have two product to sum formulas now. One is for sine alpha, sine beta. One is for cosine alpha, cosine beta. Using the similar technique, we can work with cosine function, sine of a sum and sine of a difference. Now let's use these two formulas. These two, sine of a sum, sine of a difference. Sine of a sum, we know this formula, right? Sine of a difference of alpha, beta, alpha and beta will be this formula. And then what if we do a subtraction? Subtract the second equation from the first equation. So let's just, the left-hand side, we do a subtraction, subtracting then we get this. The right-hand side, when you subtract the second equation's right-hand side from the first equation's right-hand side, what happens? This will be canceled, right? Because we have two identical terms. So sine alpha, cosine alpha, once you do a subtraction, it's canceled. But when you subtract this by because we subtract a negative, right? Subtract a negative of this term from that means adding. So that's why we have a twice of the cosine alpha, sine beta. So after you do a subtraction of the two equations, we get a new equation. That is a new identity. That is true for any alpha and beta. But since our current goal is to write product to sum, so we focus on this product. So let's put that on the left side. And after you divide the two, so you divide the two, right? So then we get that product. So if you divide two, both sides of the equation, you can get this product, which is cosine alpha, sine beta is half of this. The difference of two functions. So now we got another formula. It is a cosine alpha, sine beta. This product can be written into another alternative form. So the third, this is another formula that we can write product of functions into is the sum or difference of two functions. And again, we can, if you do the difference of the two equations, right? Let's do addition of the two equations. If we do addition, we do a sum of the two equations, what happens? So just do addition, left and right. So these two terms have opposite signs. Then we can cancel each other. And the first term, that means we add these two, that's twice of that term, sine alpha, cosine beta. So we can get twice of the sine alpha, cosine beta if we add the two formulas. And then this is another formula. So this formula can be simplified if we divide two both sides. Then you see we can express this other product, which is sine alpha cosine beta, into the sum of two functions, two function values. So that is another formula. Which is this, when we try to add the sine of a sum and the sine of a difference formulas together, and then we end up with a new formula. And so now we have derived 4 formulas, and we call this set of 4 formulas product to sum formula. So let's look at these 4 formulas that we derived so far. So put them all together, and from the formulas you can see how we derived them, right? Yeah, by adding these two identities we get this. Yeah, so or by doing difference or sum of cosine identities, by doing the difference or sum of the sine, the identities for sine, then we can get this 2. So we get a total of 4 formulas. And this group of formulas can allow you to rewrite a product form, no matter it's a product of two sine functions, or product of the cosine values, or product of a cosine with sine, product of the sine with cosine. You can always write it into the difference or a sum. So with these 4 formulas, let's use them once to see, okay, some applications. So let's keep these 4 formulas handy, and if you can memorize them, that's even better. So let's say we have this problem. We want to write each product as a sum or difference. So the first question is sine 6 theta, sine 2 theta. So look at the 4 identities. Which one is in this form? It is a product, right? Product of a sine and another sine. So we can use the first because that's sine of a certain angle. This is our alpha, beta, right? First angle is that's alpha and beta. So we just see that this first formula can apply to this. And then we immediately, our alpha is 6 theta, beta is 2 theta. So we can use the formula when alpha is 6 theta and beta is 2 theta in the formula, right? It's a sine. And then all we need is to just put 6 theta and 2 theta inside the formula, 6 theta and 2 theta. And then by applying the formula, because the first identity is true, all these four identities are true for any alpha beta. So it's a very special case. So when alpha is beta are given as this, we just write this as half or negative half. That's the negative half. Cosine alpha plus beta, which is 6 theta plus 2 theta, 8 theta, and minus cosine alpha minus theta. So 6 theta minus 2 theta is 4 theta. Now we have achieved the purpose of writing the product into difference of two trigonometric functions. So let's do another problem. Another problem is sine x cosine 5x. So how do we write this product as a sum or difference? Sine x cosine 5x. So we see it's a sine, a product of sine cosine. So the last formula can be applied. So here, what is alpha? The alpha is simply x here, right? Beta is 5x. So all we need is to put x and 5x to replace alpha and beta respectively in the formula. So x minus 5x. So we just replace alpha and beta. So in this formula, so immediately we get this should be equal to half of sine of the sum of the two, right? Then you see x plus 5x. And plus sine the difference of the two, which is x minus 5x. Yeah, so we can just simplify it. It is a sine, when you add them, it's a 6x plus sine x minus 5x is negative 4x. But of course, sine is odd, so we can put a negative sign outside. So we can rewrite this negative sign can be moved. So sine of a negative is negative of sine 4x. So this is the final version to write this product. Now we have already rewrite the given expression as a sum or difference, right? We achieved that purpose. Now, what if you want to write so we can write the product into sum or difference. What if you want to write sum or difference into the product? See, the four formulas we got so far, we go from the product to difference or sum, right? We can use any one of the four formulas. But what if we want to go from the sum difference to the product form? Sometimes we prefer the product form than the sum or difference. So in case that is the case, then you can use the formula, right, in either direction. So we have gone from the product form into this, yeah, sum or difference. Yeah, this is the use of this formula. However, sometimes we prefer to go from this the difference or the sum into the product form. So that's another way we use the identity. Either way is fine because they're identities, right? Each one is an identity. So both sides are the same. So depending on which form you want. So how do we do that? Then first of all, for our convenience, we can put, so this time we want to get the product sum given this difference. So let's just simply move the number to the other side. You multiply a -2, right? Multiply -2, then this one will be gone. This will have a -2. Multiply a +2, this will be cancelled with this, will be 2. Multiply both sides by +2, you will have 2 here. You will have a 2. So these four formulas immediately will become different look. It's just try to put 2 on the other side instead of half on this side. So we get, yeah, we just put these formulas in this way so we can see, yeah, same four formulas except the 2 is now on the other side, right? So, and also with for the above four formulas, they are essentially this, because we want to go from the difference or sum. So we just put the difference or sum on the left side. And then, yeah, then we can see we can possibly convert difference of our sum of trig functions into product form if we happen to have this pattern. We can make it even more convenient. How to make it more convenient? So we can see that change of variables are always convenient. Let's call this one A. This angle is A. And the difference, let's call it B. So that means we just simply want to, so if alpha plus beta is A, alpha minus beta, we call it B, then what is alpha? From here, then we add together, we know 2 alpha, we add both sides, we add the 2 equations. 2 alpha must be A plus B. So alpha can be written as half of A plus B. Yeah, so because that's, yeah, so let's just call this as A, like, yeah, every time you see alpha plus beta, let's just simply call A, a certain A, right? Whenever you see alpha minus beta, let's simply call it a B, because that's more convenient for our current purpose. So let's call it B. It's again a change of variable. Change of variable is, you will see how convenient very soon. So after we change the formula, because we want to use AB, not alpha beta anymore, right? So the alpha beta has to be replaced in terms of A and B. So you see alpha will be half of A plus B. So let's replace it. Alpha is half of A plus B. Then what about beta? Beta, yes, we can also do that. Some from this tool, let's just simply do the subtraction, because once you subtract the 2 equations, alpha can be eliminated, right? alpha will be eliminated. And then you subtract the second equation from the first, you get 2 beta. Two beta when you subtract second equation from the first, 2 beta. So that's A minus B. So what is beta? Beta must be half of A minus B. So now the beta can be replaced as half of A minus B. So every time you see the beta, you just replace it with half of A minus B. So all this beta will be replaced as half of A minus B. Half of A minus B. Because we're doing the change of variable, because alpha beta should disappear from the formulas. Alpha is half of A plus B. Beta is half of A minus B. Now we get, after changing, the look of the four formulas will be different, but they're essentially the same formulas with different names and more friendly. So let me give you a clean version of these four formulas. So that's the process. And after we do this analysis, and then you can accept this is a clean version of the first formula. And then for second formula, after, right, we change your alpha and beta with, in terms of A and B. So you see this is alpha, beta all replaced. And of course, alpha plus beta, alpha minus beta also replaced. And then we get 4 new formulas. And these 4 new formulas, the purpose of each formula is, you see, from sum or a difference into a product form. Yeah, either difference or sum. Now convert it to product. So this group of formulas will allow us to convert from difference or sum to product. And let's use it once. So suppose we have a problem, cosine 7x, cosine 3x, you have a sum. Can we write it into a product? So check on these 4 formulas. Can any one formula be applied? So you see the cosine, the sum of 2 cosine. So cosine 7x cosine, so cosine plus another cosine, the second formula should work. Okay, so here A is the 7x, B is the 3x, right? That's the case when A is 7x, B is 3x. Then we can immediately apply this formula. So just to put the 7x and 3x for A and B respectively, right? This is a minus, this is a plus. So you just put in the formula. Then let's work on this problem. This is the problem. Cosine 7x plus cosine 3x. We want to write this sum as a product. As a product, we are using this second formula, right? It should be twice of cosine half of A plus B. Half of A plus B, so 7x plus 3x times cosine half of A minus B, so 7x minus 3x. Now let's simplify it. This is actually 10x, right? 7x plus 3x, 10x over 2. 10x over 2 is 5x. And then 7x minus 3x is 4x. 4x over 2 is 2x. So that's the reduced form. And so we now have achieved from the sum to the product, sum to a product. Now another question. So here's another. This is a difference. We want to write it as a product. So difference, sine 9 theta minus sine 3 theta. Which one? It is a sine, yeah, function minus another sine. So we can use the third formula. So here in this case, A is 9 theta. B is 3 theta. You see, we have a problem, sine 9 theta minus sine 3 theta. So if A is 9 theta, B is 3 theta, then you just, in the formula, replace each A with 9 theta, each B with 3 theta. Then you apply the formula, you will get the result. So let's continue. So here, using the third formula, so get twice of cosine half of the A plus B, which is 9 theta plus 3 theta, times the sine half of A minus B, which is 9 theta minus 3 theta. So we continue. We have to simplify it. So what is 9 theta plus 3 theta? 12 theta. 12 theta divided by 2, 6 theta. Okay, then now, what is the difference? 9 theta minus 3 theta. Okay, after combining, get 6 theta over 2, which half of 6 is 3 theta. So now we have written the difference as a product. Yeah, because the problem is difference of two sine function values. So we pick the third formula, right? Difference of sine function values. So we got the product form. Now, let's do one last problem. This is a verification. So we have left-hand side equals right-hand side. And we want to show this identity. How do we show the identity? We can choose, for example, from the left-hand side. We cannot reduce it. But if we can write numerator as a product, denominator as a product, then hopefully we can maybe cancel some common factors if there are any, right? So we're going to think of writing the numerator and denominator into product form. So sum to product formula in order to cancel some common factors. So let's use that approach. So you see sine plus sine in numerator, cosine plus cosine in denominator. Can we go take a quick look at the four formulas? Sine plus sine, yeah, this is the formula we can use. Cosine plus cosine, that's another, yeah, that's the formula. Okay, so remember, so we are going to replace, right? Sine plus sine. But that's just the name. You see in this problem, we are seeing alpha and beta. That's okay, but just in the formula, we use alpha beta, right? It's just the name. So if A, this first angle is called alpha, if the second angle is called beta, then using this formula, there will be alpha plus beta, alpha minus beta. So it doesn't matter. So it's still the same formula. So same thing, if this is alpha beta, then just get the same identity, right? It's true for whatever two angles. So now we are ready to to do the so you can see the numerator, I use a color pink. Denominator, we use a color blue just for you to see quickly. So the numerator is written right using the product form. It's the sum to product. And the denominator, you see, cosine alpha plus cosine beta is also sum to product form based on the above the previous four formulas, sum to the product form. And then once we have this, immediately we write numerator denominator as a product, then we can cancel common factors. Do we have common factors? Yes. See, that's a common factor you can cancel. And the 2 is also common, you can cancel. And then what is left? The left is the sine of this angle over cosine of the same angle. But quotient identity, you see, sine over cosine is a tangent. Is sine of this angle over cosine of this angle will be tangent of this angle. So, and that's the right-hand side. So this identity is proved. Yeah, so just a quick view. We're trying to show this left-hand side is equal to the right-hand side. And here we have verified. Yeah, we started from left-hand side and then using the sum to the product formula, and then we achieved the right-hand side. And so identity proved.